Calculus Foundation Mastery Method FM2. Max, mean and inflection point. Let us take an example. F of x is x to the 4 over 4 minus x cubed plus 4. We'll try to find all the properties of this function, like where the function is increasing, where it is decreasing, if you have any max mean, and then we also see if this function has somewhere change of concavity, and will determine the inflection point. So for all this purpose, we need to find a couple of things like first derivative. The first derivative is straightforward, is a polynomial kind of functions, and you can just use power rule. So the first derivative is x to the 3 minus 3x squared. Now for the critical points, we need to solve the first derivative. So x to the 3 minus 3x squared equals 0. Now we can factor out x squared, and then remaining factor is x minus 3, which is equal 0, and by the 0 property we can just say x squared is 0, that means x is 0. X minus 3 is 0, that means x is 3. So we got 0 and 3, these are the critical values of this function. Now we'll find some more information for the inflection point. So we go to the second derivative, starting from the first derivative. So we get 3x squared minus 6x, and again we write this one as a factor form. We can factor out 3x, remaining will be x minus 2. And then for inflection point candidates, we want to solve this one too. So you have 3x times x minus 2 is 0, and that gives me the 0 property. X equals 0 and x equals 2. Now we'll do the analysis. First, let us look at what happens when f prime x is 0. We take a number line, put our critical values 0 and 3, and then we'll be taking some test points. -1 on the left side of 0, 2 is between 0 and 3, and then 4 after 3. Now let us look at the sign of first derivative, which is x squared times x minus 3. Now we'll be posting the test points for x and see the sign. If you replace x by -1, so x squared times x minus 3 gives you a negative answer. So we put a negative sign. Now let us plug x equals 2 for x, that also gives a negative sign. When we plug x equals 4, we get a positive sign. So now what happens to the graph or the function? Negative derivative meaning is the graph is going down like this. Again negative, so it goes down. And then we got plus sign after 3, so that goes up here. So the analysis, now we can say the graph decreases on -infinity to 0 and also 0 to 3. As we have mentioned, this is a polynomial function. So the domain is all real numbers, meaning it's -infinity to +infinity. And the graph increases where we see the positive sign after 3. So it goes from 3 to infinity. And as you see how the graph is going down and up, so at 3 we can see the function has a minimum value. Second part, we check the interval of concavity. So second derivative equals 0. When you use the points, we got 0 and 2, we put it on the number line, 0 and 2. We'll be taking the test points again. Left side of 0 is -1, between 0 and 2 is 1, and after 2 we take 3. Let us check the sign of second derivative now. -1, if you replace for x in second derivative, you get a positive answer. And then when you plug 1, you get a negative answer. And when you plug x equals 3, that gives you a positive answer. So now what happens to the graph? We know second derivative positive meaning is concave up. So we put this symbol for concave up. Negative meaning is concave down, and then again positive is concave up. So now we can conclude like this. The graph is concave down on 0 to 2, and it should be open interval. And the graph is concave up from -infinity to 0 and then 2 to infinity. Now, since we see the change of concavity in each candidate for 0 and 2. It goes left side of 0 is concave up, right side is concave down. So this is inflection value or inflection point. And then also 2 is inflection point. And we are done. Thank you.